So welcome, Michael, and welcome to AU. We'll probably have a few more students popping in, but if not, or if you're watching this as a recording, welcome. I'm Mrs. Nedved, one of the high school math teachers here, and as you see on our screen, we have Michael Temple, who is my little brother, and I still think of him as little, but he's well into his 20s, so no longer little, but I also have always called him Mikey, so I will try to be professional. I told him I try to call him Michael, but he does also respond to Mikey. Anyways, he is here to talk to us about his job as what I would call computer programmer, but I know that he has a more specific title. And those of you who were in my math classes, we talked about already in DI this week, but how he did also get his undergrad in math. And so we can kind of look at how we can use math as a degree and what that applies to in the field beyond college. So as we go throughout, if you have any questions for him, feel free to throw those out in the questions box. Now those are going to show up on my end of the screen, and then I'll pass those along to Michael either during or at the end. We'll have all the time for Q&A as well. And if you're watching as a recording and you'd like to reach out with any specific questions, just send those to me, and I will get those on to Michael and get answers for you. If you don't know how to get a hold of Mrs. Nedved, get a hold of your homeroom teacher, and they'll get that on to me as well. So I believe we're ready. Michael, go ahead and take it over.
Hi, I'm Michael Temple. I'm a software developer down in Austin, Texas right now. Like Melissa said, like Ms. Nedved said, software developer, computer programmer, software engineer, whatever, it all means the same thing. These are pretty imprecise terms, and they encapsulate a lot of different kind of things that you can do in the technology world. So it doesn't really matter. Software developer is probably what I would call myself, but it's basically the same. So I'm going to start out by telling you sort of my path through the software development world, how I got started, because while it's not technically probably the most generalizable way through, I think it'll show you that it's the doors are a lot more open than they might seem. It's a lot easier to get into this world, even if you don't feel like you have the necessary training right away. So I was a math major in college. When I went to college, I didn't really know exactly what I wanted to do with my life. Some people do, such as Mrs. Nedved. I think that she kind of always wanted to be a teacher, or did at least knew that when she was graduating high school. I didn't really have any idea, so I decided to be something a little more general, keep my options open. I knew I was pretty good at math, so I just decided to be a math major and see what opportunities came to me. Went through a lot of different application cycles and down a lot of different paths as an undergrad in college. I thought I was going to be an actuary for a while, so I took some of those. I don't know if you know about the actuarial exams, but they're like these big math tests you have to pass in order to get certified as an actuary. Took some of those, but they're really long. You have to take a lot of tests, including after you graduate college, and I wasn't like too keen on that, I realized. I got a job offer to work for this big data company, which would have been maybe cool, just like work enormous amounts of data and trying to aggregate it in certain ways using my math skills. But I would have had to do training in India for 6 months, and I wasn't so sure about that. Maybe it would have been fun, maybe not. Interviewed with an options trading firm, so we'd be like setting markets and basically trading stocks, high frequency stock trading on Wall Street and on the Chicago Financial Exchange. And just like a bunch of different business analysts. If you have a math degree, you can apply to pretty much any business analyst job. And like business analysts, software development is really amorphous. It doesn't really mean any specific thing. I don't know if you guys ever read Richard Scarry books when you were a kid, but I heard he was a children's book author that would like show scenes from a city and just like people going about their day. There were little animals that were doing jobs, and it's like we know what a policeman and a doctor and a fireman do. It's sort of hard to define what a businessman does. He just does business, and business is as variable as it comes in the professional world. And so that's sort of how software development is also. You have this toolbox that helps you accomplish something, but that something can be literally anything. So it's kind of nice to have the ability to insert yourself into all these different industries. So I was in healthcare originally. I now work for an auto insurance company as a software developer. But basically, the types of things I had to know didn't really matter what the specifics were. It's just about manipulating data in a way that someone on the business side tells you the data needs to be manipulated, so you're really flexible that way, I guess. So I didn't really take any computer science classes when I was in college. And I said as much in the interview for the job I wound up taking in Chicago to be a software developer. I said, I don't really know how to do this. And the CIO from that company had gone to my university, and he wanted to build this team of recent grads who could kind of come up through the company. And so he just said, basically, we think you can figure it out. We like people who went to your university, and you could probably just learn on the fly, which is what I did. I had a math degree, which was probably helpful. It's probably helpful to have something in the STEM field as far as a degree goes, but it's not necessary. One of my best friends at my old job was a software developer, was an English major at the University of Notre Dame. And he just said, yeah, I'll give this a try if you'll let me learn. And so right away when we started, there wasn't a whole lot of work for us to do. So I would basically just gun tutorials online and try and learn as quickly as I could the kind of concepts I'd need to be working with, even if I didn't really have that great of a foundation originally. So I thought that would kind of change, but it really doesn't, to be honest with you. Before I was a software developer, I had this idea of this like black box idea of software developers. Like some people don't know how to software develop and some people do. But once you get over this event horizon, it becomes pretty clear that everyone is just like most of the things you do every day you haven't done before. So you're kind of spending your entire day on Google and on places like Stack Overflow, which is a website for developers where they can ask each other questions to try and tackle these problems, because it's not very valuable to be able to do exactly the same thing over and over again. You need to be able to solve hard problems and make build programs or applications that can do things that are really variable day over day. So the software development community in the world is like really, really helpful. Sort of the ethos of the whole community is to help each other and to have all this open source software, for example. So they'll develop things and then just put them online for free. It's kind of their guiding principle, which is really helpful. So you can go on somewhere like Stack Overflow. I've done it a lot as when I was learning as a developer, and still today all the time. If I have a specific question, there's so many people on there that you can just kind of Google around and try and find that someone has asked a question like that, or a question similar, or exactly that question, and they'll help you solve some piece that you're stuck on. Or if not, you can ask questions directly. And honestly, within like 20 minutes, someone will have responded to your question. There are often multiple responses that you could have, different approaches to the problem. And
hey, Michael.
Yeah.
Oh, I just had a question come in asking if you ever use GitHub, GitHub. Do you know what that is?
Yeah, absolutely. So when I was talking about a lot of open source code that exists in the world, a lot of it goes on GitHub. So GitHub is like an online repository where you can develop things in any language and post them to that repository. And then if you can adjust the permission statuses on them, but if you make it public, then I could go out there and download whatever you had developed onto my local repository and either use that code directly or manipulate that code for my own purposes. and insert that into whatever development I'm working on. GitHub is an incredible resource, and it's very cool. It's something that I don't feel would exist in most industries. It doesn't exist in, like, there's no such thing as like proprietary information, it seems like, in most of software development. So much stuff is free and open source, that you can really get like a completely free education and really get started on this kind of stuff. So GitHub is a great location to get started there, I think. I, for example, I'm right now working as a C# developer. I originally started as a SQL developer. SQL is like, basically you can think of, I used to work with relational databases, which you can think of as just like many hundreds of Excel sheets stacked on top of each other, because it turns out that if you're managing a bunch of different data, I used to work for a health insurance company, so we'd have to manage things like claims that came in, the doctors that were in our network and the members that were in our network, and basically hundreds of individual pieces of data, thousands. And it turns out that the best way to store that is not just in like one big spreadsheet or something like that. It's really hard to retrieve the kind of data that you need. You instead want to break that out into as many small tables as you can, small spreadsheets basically as you can, link each piece of data by keys to anything else that it might relate to. And then it was my job to develop the queries that would read from those many hundreds of tables and produce specific pieces of data that my company might need, or update specific pieces of data in order to keep that data specifically curated such that we could pay claims accurately. That's what I used to do. Now I'm more of a C# developer, which is a lot more powerful tool than SQL. C# is an object-oriented programming language, whereas SQL was just a querying language. You just ask for data from a relational database and it would return that data to you. Object-oriented programming languages, you can basically build anything. It can read files or read databases like that too, but it can also basically perform any function that you want it to if you're able to figure out how to make it do that. So I work with C#. Yeah.
Just had one more question, sorry. Do you, and I'm gonna probably butcher this too, do you ever need to learn, I would say data science, but maybe DAT science with SQL? You know what that is?
I don't know exactly what that's referring to, but yeah, if they could clarify the question, that'd be great. But I'll say.
Data science. Sorry, data science with SQL.
Yeah, so I'm not really sure how to answer that question. So when I was saying SQL, that's SQL. That's what I was referring to. It stands for Structured Querying Language. Do you need to learn data science specifically? You just kind of need to learn how the syntax of SQL works, and you kind of need to just play around with it and start to understand how the relational database process works. So data science definitely would help you in that endeavor, but you don't necessarily need to. I never took specific like data science classes or anything like that in college. I just was kind of thrown into the fire, and you can pick it up. SQL, I think, is I would say is a really good place to start. It's a pretty easy language to teach yourself. It's imperative, which means that you tell it exactly what to do and it returns that data to you, and it comes in really quite handy. So basically, long story short, you're never really like a complete developer. You're always learning new things. That's a really important way to approach software development. Is you probably won't know how to do what you're supposed to do like this very moment, or you won't know exactly how to do it. You'll have to play around. You'll have to try some things and see how they work. And that's just the process of building something from scratch. But it can be really interesting to tackle those problems, and it can be really rewarding to complete them. So I'd say the best aspects of being a software developer, probably people at this school know as well as anyone that locational flexibility, it can come in really handy. It can be incredibly convenient. So I do go into an office most days, but I don't have to. I could do my entire job anywhere with that. I took my laptop that had an internet connection. If you're not feeling well or whatever, you can stay home, work from bed. If you need to take your car in or go to a doctor appointment or something like that, basically there's no sort of like micromanagement or anything at either of the companies that I've worked at. If you have an internet connection, you can just go basically work from anywhere. I could probably go on vacation and work from wherever that was. So it can come in really handy for just navigating your other aspects of your life. I've got coworkers who have kids, and traffic here in Austin can get really bad around rush hour. So they'll just like take their kids to school in the morning, hang out, work from home for a few hours, come into the office like over the middle of the day once traffic dies down, and then leave at like 3 o'clock and finish the day from home to avoid traffic that way. Again, similarly, there's no real set hours. You're just kind of expected to get the work that you're expected to get done. Again, there's very little micromanagement with the execution and the implementation of the kind of work that you're supposed to be done or that you're supposed to get done. There's really no specific way to do this job. So I don't know if you've ever heard the phrase, when your only tool is a hammer, everything looks like a nail. So there are all these different software programming languages that have slightly different aspects, and everyone has like their favorite version of their favorite programming language, and they can all approach different languages slightly differently. If you asked 10 developers to do some process for you, I'm sure they would come up with 10 different implementations, potentially in 10 completely different programming languages. But the end of the day, maybe they are hammers, but they are incredible. They're more like Swiss Army knives. They're incredibly useful tools that can kind of be bent to our will in any way. So you really have a lot of flexibility to just play around and learn and figure out what works best and what doesn't work. And sometimes you wind up going down the wrong path. You have to circle back and do some reconfiguring, retooling the code, but you've got a lot of flexibility to be able to do that. I would also say that like environment and culture, pretty laid back environments in the tech world, especially in sort of tech hub cities. I know if you're in like a smaller company and you might be the only software developer, then this might not necessarily hold. But if you work for a tech company, they kind of pride themselves on having fun, having a loose environment where everyone can enjoy themselves at work. I've definitely found that to be true. You get to tackle engaging problems. You're kind of given free rein to just figure things out on your own, which I find to be really empowering. And it pays well. It's a professional degree, or it's a professional position, and you're compensated pretty well. So I would say that it's in all a really great career to consider. The worst aspects of it, like if you do run into a problem, it can get kind of tedious to try and debug and figure out where the problem is in your solution. But it all just comes to territory. Documentation, another like sort of tedious aspect of it. It'd be great if you could just sit down and power through and keep building and building and building, but eventually you have to circle back and let people know what you built and why you did things certain ways, why you implemented things certain ways. I found that I was in a lot of meetings, especially in my old company. I had like carved out a portion of the company that I was pretty valuable in. I built this process that was pretty useful. And once I had done that, I found myself being pulled into a bunch more meetings, and that was one of the reasons I decided to change careers. I liked more of the development than the meetings, but they kind of go hand in hand sometimes. And then the abstractness. When I was back here talking about the best aspects, it sort of depends on your personality, whether you think like the fact that there's no specific way to do anything that you're doing day over day. That can be sort of daunting for certain people. there's this philosophical or this psychological concept called the paradox of choice, where the more choices that you have, it can like paralyze you to actually make a decision. So if you're not that kind of person, then it can be hard to decide what the best implementation of a certain process or piece of code can be, because there are so many different ways that you could potentially do it. But I guess that's basically just a personality type thing. But I think that software development is, if you have the right kind of mind, it can be really rewarding. So I was supposed to talk about an interesting thing, some interesting parts of my job, and maybe my job, it would like take a while to describe the way that the things that I think are interesting are actually interesting that have happened to me. But here's a couple of interesting things that have happened in software development generally. In 2012, there was this options trading firm called Knight Capital Group that they implemented a new piece of software and deployed it, but there was an issue with the deployment. They only deployed it to like 7 of their 8 machines that they needed to deploy it to, and they missed it on this 8th machine. And what I wound up doing is inadvertently trading over and over and over again to the tune of like losing the company $162,000 a second. And they didn't catch it for 45 minutes, and it wound up completely bankrupting the company in 45 minutes because of a failed deployment. And on the right, there was this thing called left pad. So another part of this is another aspect of open source computer programming. There's this guy who's just like developing a bunch of really useful tools in this language called JavaScript, which is what the internet basically runs on. And he had deployed a bunch of his stuff to the central repository where anyone could go and get that code and use it in their code or reference the code as it existed in the central repository. And he got in a fight with the people who managed the repository, and he pulled all of his code off. And since so many things use this, this is a really simple piece of code. It's called left pad. All it does is pads with zeros to the left of a thing, like some string, in order to make it X number of characters long. But it had been downloaded like 2.5 million times in the month before he pulled it out. And so when he pulled it out, it like brought literally 25% of the internet. It made those whatever websites reference that not work until they went back and did some debugging and re-added something that did the same thing back in. So I talk about that because I think it's illustrative of how complex the technical world can be. There's this thing called normal accident theory. The other day I was bored at work a little bit, so I was reading about the 3 Mile Island nuclear meltdown. And this guy named Charles Perrow came up with this idea of the normal accident theory, which is that in extremely complex and highly integrated systems, even really standard, really normal, expected accidents can kind of spiral outward and cause huge, huge problems. You know, just a failed deployment in the case of Knight Capital Group, or pulling an incredibly simple piece of code in the case of left pad, wound up having these enormous impacts because of how tightly coupled and integrated the technical world can be sometimes. But that also really opens up a lot of opportunities to work in technology. So, for example, I'm a developer. That's like maybe the most common way that you can work in technology, but there are entire people whose job it is, like in my old company, there's entire teams whose job it was just to manage the databases, not the actual data, which you would think is the important part, but just making sure that the databases and the servers were running so that you could put data in and pull data out. And in the example of left pad, it would be like, if those failed, then it wouldn't really matter what the data is because the databases couldn't be accessed. There are entire people, entire divisions at my current company that just deal with deployments. So people are coding and building things all the time, and their entire job is just to set things up so that they can get into production. Because in the case of Knight Capital Group, if you fail a deployment, it can cause really devastating impacts in your production environment. So that's the kind of like really nuanced, specific stuff that they could never teach you in school, even if you were a computer science major. Um, so I think that really opens the door to being able to learn on your own something specific and still be able to carve out your place in the technology world, even if you don't necessarily have like formal training. So getting started, like I've alluded to, there's so many resources online if you really want to learn how to program on your own. Like I would suggest, if you're going into college, I would suggest focusing on something like a STEM major. But again, even that isn't really necessary. But if you just want to start trying to develop, most things online are free, so like Java is the most common programming language in the world. You can download JDK 11, which is the most recent version of 11, and Eclipse, which is an individual developed environment, called them IDEs. That's just like how you write Java. It's the platform that allows you to write Java. You can download both of those things for free and just go at it. Google Java tutorial, and there's probably hundreds available. Similarly, for C#, you can download something called VS Code, and you can just start developing in C# for free on your local machine. I don't know specifically about all the rest of these, but I'm sure it's the same way. You can download and get started for free. SQL, you can do the same thing. There's something called Postgres that will let you set up your own local relational database and load whatever data you want to and start playing around with SQL and you can build really powerful things with all this free software. So I would say if it at all interests you, don't wait for a professor or a teacher to start telling you how to do it. Just start doing it. It's I'd say one of the highest paying professions that you could really entirely teach yourself. I work with people who don't have college degrees, for example, and are incredibly good developers. It's probably harder to do these days. They've been in the business for a while, but it really can be self-taught. I would say I'm almost exclusively self-taught at this point, and I think that opens up a lot of doors. Salary and growth. I don't know if you guys in your math classes have gotten to normal distribution yet with bell curves. I'm very skeptical that each of these breakdowns of this bell curve are 25% of whatever's underneath the bell curve, but that might be splitting hairs. Basically, this is about correct. When I started, I was somewhere to the left of that, in the bottom quartile. Within about a year, I was in that second quartile, and now I'm right around the median after about 4 years, and I'm still learning a lot. So there's definitely room to grow in this industry, and I just think that generally it's a really great industry if you've got a sort of analytical mind and you want to be able to leverage that. That is all I've got. So.
Awesome. Well, thank you. I know I learned a lot. I did have a question come in, and I think that you kind of covered it, but the question was, will computer science degree help becoming a software engineer? I think you basically covered that, but.
I would say it definitely helps if you know that that's what you want to do. But it's also not necessary. If you think you want to do that, I would definitely try and focus on that, but you definitely don't need a specific computer science degree in order to get a job in computer science. And you can really teach yourself, you can get yourself started on your own basically today if you want to. There's so many resources available online that you don't need to wait for that. Even if you know that you are interested in that, you can kind of start playing around with it and see if you enjoy doing it.
Awesome. Yeah, I think that's so interesting. Like you said, so rare. Ayo, but did you have any other questions for Michael? Or Michael, did you have anything else you wanted to cover?
That's all I've got.
All right, awesome. Well, again, if you are watching as a recording and you want to pass any questions along or speak with Michael, just get in touch with Mrs. Nedved, and I'd be happy to do that for you. Otherwise, just a big thank you to Michael for coming and presenting for us. I think it was, I learned a lot, even though I guess he's been doing this for, what, he just said 4 years. I feel like I had no idea any of this. That's a good big sister I am. But thank you, Michael. Thank you, those of you who are attended, and have a wonderful rest of your day.
Thanks for having me. Bye.
Bye.